Most of us are familiar with the principle of one person, one vote, and in democracy this often means equal representation. That means no matter who you are, your vote towards your elected representatives, such as your senators, presidents, mayors, counts the same, just as everybody else's vote. But often when you move away from politics, this is not true. For example, think about a company. The company, when decisions are made, you have to take into account the decisions of the CEO, decision of regional managers, sometimes even decisions of employees. And obviously an employee does not have the same amount of power as the CEO. That means the CEO has more votes in a way. So this is called weighted voting, where not everyone has the same amount of votes, and for a good reason, because the power is distributed differently in these corporations or sports teams and stuff like that. So here we have a small example. Before we get into something big like the United Nations, let's talk about just a quick few basics. So here we have a school, let's say. The school has a principal, 2 board members, B1, B2, and 3 teachers, T1, T2, and T3. And they all have different amounts of votes. The principal has the most votes, 4. Each board member has 2 votes, and each teacher has 1 vote. And it turns out that the quota, or how many votes are needed to pass a decision in the school, is 7. So this is how we illustrate a mathematical weighted voting system. We illustrate it by first putting the quota, how many votes are needed to pass a motion. We put a colon, and then we list in descending order the amount of votes that each person has. So the first person will always be the most powerful, and the last person, or people, if they're the same equal number, are going to be the least powerful. They have the least say in decisions. So now let's talk about winning and non-winning coalitions. Obviously, you might have thought of, there's many different ways to get something to pass. For example, the principal could vote, and then we could have 3 teachers. If you just ignore the board members, this still passes, right? Because it's 4, 5, 6, 7, which matches the quota. So there's obviously many different winning coalitions, and I've written just a few here to illustrate what could happen. So the first one I talked about is here, where the board members vote differently, but it's okay as long as the principal and all of the teachers vote that way. Or you can have the principal, 1 board member, and 1 teacher, because that's 4, 5, 6, 7. Or you could ignore all the teachers, and then you only need the principal and 2 board members. Or you can have the most interesting one of all is if you just ignore the principal altogether. This voting system is made so that if you ignore the principal and everybody else says yes, but everybody has to say yes, you can have B1, B2, T1, T2, and T3. Then this is exactly how many votes you need to get this to pass. Now there's also non-winning coalitions, which you probably figured out are coalitions that do not get enough votes. For example, if you just have the 3 teachers, it's not going to pass because that's just 3 votes. If you have a board member and 3 teachers, that's still not going to pass because that's only 5 votes. If you have the principal and just 1 board member and nobody else is on board, not going to pass. Or if you have just the principal, it's not going to pass. So this is kind of a good voting system because it doesn't put all the power in the hands of the principal. For example, if the principal is okay with it, then and nobody else is, it's still not going to pass. So it's kind of fair, but at the same time, the power is distributed differently amongst different people. So now we want to ask the natural question. We know that the principal seems to have more power, and the teacher seems to have the least power, but how can we quantify this? How can we have numbers that tell us exactly what % of the power they command in this voting system? Well, there's different ways to do this. In this one, we'll talk about something called the Banzhaf Power Index. This is named after a law professor who came up with the system, and it's pretty straightforward to calculate. So let's go ahead and see. Now, before we calculate it, we need to talk about the last thing, is critical players. So I've written here 2 different winning coalitions. Let's first make sure they're winning coalitions. P is 4, 5, 6, 7, so this wins. This is a winning coalition. Is this a winning coalition? This is going to be 4, 5, 6, 7, 8, 9, 10. This is going to be a winning coalition because that's 10 is over 7. Now, a critical player in any winning coalition is somebody that, if you take them out, then this becomes a losing or non-winning coalition. So notice in the first one, these are all critical because if you take any one of these people out, then this does not win anymore. For example, let's take out the principal. Then we only have 3 votes, and this motion will not be passed because you need 7. What if we take out a teacher? Well, then this is going to have 4, 5, 6 votes, which is not enough. But in the second one, the only critical player is the principal, because if you take out anybody else, this will still pass. For example, let's take out a board member. Then you have 4, 5, 6, 7, 8, which is more than 7, so this motion passes. You can take out a teacher. It's going to be 4, 5, 6, 7, 8. This passes. But if you take out the principal, you have 1, 2, 3, 4, 5, 6, which is not enough. So the principal is critical here. So the Banzhaf Power Index relies on some players being more critical than others and their critical counts being higher. So let's see what that all means. So first thing we want to do is write out all of the winning coalitions. This often seems like a daunting task, but in future videos, in fact, in the next video, we'll talk about how to make this more manageable. But for now, for the sake of this example, let's just write them all out. First, notice that a winning coalition has to have at least 3 people, because if you have only 2 people, it can't win. Because even if those 2 people are the people with the highest power, let's say principal and B1, that's still only 6 votes, not enough. So you need at least 3 people for this to be a winning coalition. Now I've written all of the winning coalitions of 3 people here, and it turns out everybody is critical in all of them, because if you take out anybody from any of them, then they all become non-winning coalitions. So I've underlined in orange all the critical players. Now if you look at the winning coalitions of size 4, notice that the size 4 winning coalitions all have to include the principal, because let's say you don't include the principal and you include the top 4 other people, that's only 1, 2, 3, 4, 5, 6 votes, not enough. So these winning coalitions, for simplicity, I put principal plus and then any combination of 3 people. So we have it turns out there's 10 of these 4-player winning coalitions, and it turns out that the principal is critical in all of them, and also board members are critical in some of them, and teachers are only critical in the one that contains only teachers. Okay, so now let's look at size 5. I put on this paper size 5 winning coalitions. Turns out there's less of them, and we put all the critical players with orange lines. And size 6 winning coalitions, you guessed it, there's only 1 of them, because there's 6 players, so you can only have the only one is with all the people. And notice something interesting here. These 6 people all add up to 11 votes, and it turns out nobody is critical in this one. You can take out anybody and the motion will still pass. So in this one, nobody has that much power, really. Okay, so now the last thing we need to do in this method is to calculate. We need to calculate how many orange marks are there total. So it turns out that if we add up all the orange underlines we see, and be careful in this one because there should really be a P in front of each of these 10, so you need to make sure you count that P 10 times. If we count out all those orange marks, it turns out there's 50 orange marks. And how many of those are P? So how many of these orange marks are under the P? Turns out there's 22 of them under P. How many are under B1 and B2? So there's 8 under each of B1 and B2. And how many are under T1, T2, and T3? Well, it turns out there's going to be 4 under each of the teachers. So now the logical or natural thing to do would be to calculate the principal's power by calculating his orange marks over the total amount of orange marks. So 22 over 50 gives us 44%. So that turns out he has 44% of the power in this weighted voting system. Now each of the board members, B1 and B2, each has 16% because we take 8 divided by 50. And then T1, T2, and T3, we take 4 divided by 50, so they each have 8%. And a quick check to make sure we did this correctly is to see if this adds up to 100%. So we would do 44 plus 2 times 16 plus 3 times 8, and it turns out that does add up to 100%. So we have calculated correctly all the different power. And we see what we suspected. We see that the principal has more power than a board member, and a board member has more power than a teacher. But it's just interesting to see how much more power that is. For example, the principal has almost 3 times as much power as a board member, but a board member has only twice as much power as a teacher, for example. So we now have a quantifiable way to see how much power each person has in a weighted voting system just by looking at this notation right here. Okay, so now let's go into the main event of this video, the United Nations. So first we need to talk a little bit about the United Nations and how it works. The United Nations has always 15 members, and 5 of the members are permanent. They were there from the beginning. So that's going to be the United States, which will designate as US, China, which will designate as C, Russia will designate as R, France will designate as F, and the United Kingdom will designate as UK. Okay, and here's how the United Nations voting system works. For a motion to pass, it requires the yes votes from all 5 permanent members and at least 4 yes votes from 10 non-permanent members elected every 2 years. So in addition to these 5 permanent members, there's 10 other members, non-permanent, and they're rotating. They're on a rotating basis. Every 2 years, new ones are chosen and things like that. But these 5 are always here. And since they're permanent members, their vote seems to count for more, right? Under this, you would think that since all 5 of them have to say yes for a motion to pass, they probably have a lot of power. Because if even one says no, then the motion is not passed. For example, I've written just examples of a winning coalition and a non-winning coalition. Here's the winning coalition. We have US, UK, France, Russia, China, and then we have N1, N2, N3, and N4. So N stands for non-permanent. So if you have all 5, so notice we have all 5 of the permanent members right here. And then in addition, we have 4 non-permanent members, so this works. But here's a non-winning coalition. This coalition has how many people in it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. It has 14 of the 15 United Nations members. Yet notice that France is not in this coalition. They didn't say yes to this vote. So because they're not in it, it's non-winning. So just notice how much power that these permanent nations have. So before we go on and see exactly how much power they have, let's make a guess. How much more power, how much more times power do you think that the permanent members have over non-permanent? When I initially did this, I thought they would have about maybe twice or maximum 3 times as much power as a non-permanent member. So let's look at exactly how much that is. So we can go over the details of this after we do the next video, but don't worry about the math right now. Don't worry about these combinations and stuff. Let's just talk about the numbers that arise. So I calculated all the winning coalitions, and the total number of winning coalitions came out to 848. So that means there's 848 different combinations of people you can make so that each of those will win, get a yes vote, it'll be ratified. So now, how many times are United States, United Kingdom, Russia, France, and China critical? How many times do they have orange lines under them in each of these 848? Well, it turns out every single time, because they have to be in every single winning coalition, right? Because if any of them is not in a winning coalition, then by definition that is not a winning coalition. So each of them is critical 848 times. Every time there's a winning coalition, one of them is critical. So now, how many times is a non-permanent nation critical? So it turns out that it's only in the 9-player case. So in the 9-player case is where you have the 5 permanent nations plus 4 non-permanent nations. Now, in that case, if you take out any of the non-permanent nations, then that becomes a non-winning coalition because you need at least 4. But just go to the 10-player case where you have 5 permanent nations and 5 non-permanent nations. Now, in that one, if you take out any non-permanent nation, it's still going to be a winning coalition because you have 5 permanent nations and 4 non-permanent nations. So it turns out that they're only critical in the 9-player case. So you see how their power is kind of going down because they're only critical in one specific case. So that means they're critical only in 84 times. Again, we'll go over this calculation in the next video after we have a little bit more info. So each of them is only critical 84 times. Now all we have to do is just a Banzhaf power index. We have to see what's the power index of each nation. So that turns out that US, UK, Russia, France, and China, their power index is 848 because there's 848 times divided by 5,080. And 5,080 turns out to be the total number of orange underlines that we see in the whole thing. Again, we'll calculate that later. But it turns out that each of these nations has 16.7% of the power in the United Nations voting. So that's kind of a lot. Now, if we calculate for the non-permanent nations, we have 84, because there are 84 times, divided by the 5,080 total orange underlines, and we see that they're each going to have 1.65% of the power. So if this hasn't sunk in already, then it's important to note this huge fact right here. Permanent members have more than 10 times the power of non-permanent members. Notice that, because if we take 1.65 times 10, we get 16.5, which still isn't even equal to 16.7. So it turns out the United Nations is very much biased towards permanent members because they have 10 times more power using this Banzhaf calculation. So that's just something interesting to know. Do you think the United Nations was designed to be this way for all the permanent nations to have that much more power, or is it a mistake? Is it something that when making the United Nations voting system, they didn't take all this into account? So, I mean, it's your opinion. Maybe you can look up the history, but I just thought it was a really interesting topic to talk about.